Hey guys, it's Julia. Welcome back to Hardware 3D. Today we're going to be loading the Sponza scene. You know, we started with basic triangles, worked our way up to cubes and spheres. We then did the nanosuit, we did the goblin, and now we're going to load Sponza. What is Sponza, you ask? It's a pretty famous scene that people often use to test out their engines. I believe it was originally created by the people behind Crytek engine, and then they open sourced it, and it's very nice. So let's take a look. Let's take a look at it. Now you can find many versions of this online. I opted for one that has a specular workflow instead of like kind of metallic roughness PBR workflow. So it's an object file. You got your OBJ, your MTL, and you got a butt load of texture files. You can see right here already, this is a pretty involved scene. So add those files, and then I had a look at the material file, and I've seen it's kind of dumb and weird. Like, for example, look here. Well, first of all, we're not using textures for ambient, so turn that off. And bump. Yeah, no, we use normal map. We don't use map bump for our normals, so we got rid of that. And it's weird here because it's got a map bump, and then it's also got a bump. You know, what the heck, dude, that don't make no sense. And I mean, we go down here, we see bump, vase round. That should be normal map. Also, we see that they had a specular, but it wasn't being set for this model. So a lot of things, they were maps not being set. There were things being set to the wrong type. And I just took the opportunity to try to fix what I could before I even tried to load this dumb thing. A lot of times here, you'll notice something dumb. They use a diffuse map as a bump map or as a normal map. And that just doesn't make any sense. So I set that to use an actual normal map. We'll talk a little bit about bump maps later on. But you get the idea. I went over it, made a lot of changes to the materials, what kind of maps they were using. And then after that, it's just a matter of loading the scene up, and that's not too difficult, especially since we fixed that path hard coding stuff in our mesh loader. So we comment out a bunch of the models that we already had, and we add the Sponza. We draw the Sponza in here. We load the Sponza. Now, when you run this, what you're going to notice, first of all, is you're going to notice it takes an ass load of a long time to load the model. That was a long time, right? You wouldn't expect that to take so long to load. And so that tells me, and I mean, I've known this for a little while here, but what we're using to load the images, because it's the images that are taking that long to load. The code that we have for Surface, it has to go. It's too slow. Even for development, it's too slow. But that's going to be a different video. In this video, we're going to take a look at what we have here. So, first we notice, what the hell, we are in the floor. Second thing we notice, okay, we're going to have to work on the draw distance or perhaps the scale of the scene, because that's no good. And the next thing we notice is, well, I mean, these curtains, they look weird. There's lots of weirdness. There's just lots of weirdness going on here. I'd say the scene is too bright. We got too much ambient going on here. It doesn't make any sense considering our light source. So, plenty of things to get cracking at. Get it? Get cracking? Anyways. So, what's the first thing we do? Well, we fix the draw distance. That's not a big deal, right? We just changed the projection matrix. So I made it 10 times bigger. And, yeah, fixing the ambient. We turn the ambient down from 0.2 to 0.05, which is a better value. I just pulled the value out of my butt. It doesn't really matter. And we change the camera to start off in a little better position. We also changed the point light to start off close to where the camera is. And with all those changes, this is what we get. This is the Sponza scene in all its glory. So let's do a little exploration. We got the lion here. It's a little dark. We can move the light a little closer. There we go. We got the lion. Why did I say lion? We got this thing. I don't know what it is. Floor, ceiling, curtains, lots of curtains, plants, weird plants. And yeah, so obviously it's pretty cool. It's a lot bigger than anything we've done before. Also, we can see already there's quite a few issues. So, I mean, where to start? Let's start with the normal textures. So if I move this thing around right away, you can see the normals aren't facing in the right direction, right? This should be, this lip here, this little bump, because we got grooves here, so this is like a little round bump. What's the word I'm looking for? Concave? No, convex. Convex bump should be getting a highlight if the light is up here, but it's getting the highlight lights down here. So the Y's are flipped, and of course we know this is often the case with textures you download online because they are meant for OpenGL texture space, and we are using the coordinate conventions of Direct3D. So that's fairly simple. We have our command line processor that can flip those Y components. Now the problem is that there is a super buttload of normal maps, and I don't want to do it all manually. So what I do in the texture preprocessor, I create one, flip all normal maps in OBJ. So what it does, you give it a OBJ path, and it will open that OBJ with asimp. Here, it's going to loop through all the materials. It's going to check for normal maps, and if it finds one, it is going to call transform file on that, which is going to process the normals using a functor here. Now, this lambda functor, all it does is it flips the Y. So it multiplies it by this vector here. It's a Hadamard multiplication per element, and it's got a -1 in the Y, so it's going to flip the Y, leave the rest the way they are. And if you run that, you're going to get stuff like this. See, you notice here, this is dark blue purpley, and now it's a light color. Y's have been flipped. Beautiful. So if we do this, we're going to note that now, let's do a little test here. Test our normal mapping. So we're going to move this guy up here, and we move it. Now we get the highlights on the right side of the bricks here. Much, much better. But oh my god, what the hell? So, yeah. I kind of messed up the mapping when I edited all those things in the material file by manually. Obviously, mistakes are going to be made, and one mistake was made, and then it got processed, which made it even worse. In the material file, I was using the diffuse mask of the vase. I was using the diffuse as the normal map. So when our processor read that information, it said, oh, this is being used as a normal map. Let's flip the Y's, which is inverting the green channel, which makes it look like this. It's just pretty weird. So let's not do that. But instead, let's flip the Y on the actual vase thing here. This is the one we wanted to flip. Good. And change texture processor maybe. So I added a function to just flip the Y normal map on a single file. Before I had only had a function for doing it for all the normals in an object material file. Anyways, so yeah, did that. Here you can see the dumb poopy in the constructor where we are parsing our command line, choosing what texture processor function to do. Anyways, doesn't matter. What matters is we still got to fix that material file. So now instead of using vase.diff for the normal map, it uses vase.dnn. DDN. There you go. And so now if we peep the vase, it's looking much better now. Normal maps are working properly. It's good. It's good stuff. But let's turn our attention to the curtains here, because they're bothering me a little bit, is what they're doing. So if I move the Z like that, and then I move the X like this. All right. So the curtains are very shiny. They also look nasty. It's all like speckly and dumb. The speckly and dumbness is basically due to the fact that we are downsampling the textures by a lot. You see, if you downsample them by a lot, we get aliasing and moire patterns and all sorts of bad stuff. And this is going to be fixed in the next episode. But we're not going to worry about that right now. What we're going to worry about instead is these curtains are too shiny. They look like plastic curtains, and that's not in keeping with the theme of this scene. It's all about Rome. Let's get some more classy textures on here. So if we look at the curtain, we realize, well, it didn't have a specular map. So just getting constant specular reflection and constant glossiness over the whole thing. And I didn't go all out. I didn't create a alpha gloss map. But what I did do was I created a specular map where it's very dark color for the fabric and the gold parts are bright. And they're also not white. They have yellow because it's metal. Metal often has a specular with a little bit of a color tint to it, as opposed to things like plastic where the specular is generally just going to be white. So we do that. And let me tell you, already we notice a huge improvement. The fabric now looks like a fabric, like a matte fabric, not like plastic. But we still get specular reflection happening on the gold here. I think the gold is still a little too dark. I'm going to fix that later on. But I mean, if you look in here, you bring this boy down here. Yeah, it looks metallic on the gold. And it looks like somewhat like fabric on the fabric. Now, the next thing I want to draw your guys' attention to is the normal mapping on. Now, let's look at this floor here. So, I mean, it's quite dramatic, but it doesn't look too bad. But when I move the light, it looks to me like the floor is sort of creeping, like it gets too much. Like, take a look at this part here up against the pillar. When I move this, I don't know, maybe it's just me, but it looks like it's almost like shifting out a little bit. So, I mean, I had some ideas. Are these normal maps? How good are these normal maps anyways? Like, look at the ceiling here. When I move this around, it looks creepy. The texture looks like it's like stretching and bending. I don't like it. So I decided I'm going to make a function that's going to load a normal map and it's going to validate it. It's going to look at it and it's going to say, what are the normals in this thing? What do they look like? Do they have the correct length? Are they way bigger than one? Are they way smaller than one? I also analyze things like the total sum of the X and the Y components. Because if you think about it, on average, they should around average out to pointing out positive Z. But turns out that's not really true. And I mean, that might be okay, but the other thing that would kind of surprise me is many normal maps that I looked at have many vectors where the lengths are much larger or much smaller than unit length. Even this image here that I downloaded from the Wikipedia article on normal mapping, it has many normal maps or many samples here that aren't unit length, and it is weird to me. It's annoying. So after doing a little digging, I determined, because some of the parts of this model, the normals look fine. They don't have that weird creepy stretchiness. And other parts, they look funky. And I'm like, well, what's the cause of this funkiness? And that's why I wrote that analyzer to see maybe those ones had bad normals. They weren't normals. But I found that the ones that looked good often didn't have the greatest normals either. So that wasn't the factor. What I realized was if you look at all the files that came with this model, you're going to see it's got bump maps, right? Or normal maps, I should say. But it also has bump maps, but not for all things. Like, look at the ceiling. The ceiling has a normal map. It doesn't have a bump map. The bricks for the wall have a bump map. The lion has a bump map. The vase has a bump map. And we saw the normals on the vase, they looked fine. They looked really good. But the normals on the floor, the ceiling, they look garbagey. They look all melty and funky. So my theory here is that this original scene, some of the materials had bump maps and some didn't. And so for the ones that didn't have bump maps, the bump maps they were probably generated from higher resolution models. So they're very accurate. The ones that don't have those bump maps, what someone did later on was they took the diffuse map and then they just ran a kind of image processor on it to sort of fake a normal map. And so because it's just faked based on this image here, it's not going to be particularly realistic, and that's why it looks all melty when you move the light. That's my theory. Also, you might be wondering, I don't think I've mentioned it before, but bump map is often you'll find this commonly in older models. The color here indicates a displacement. So it's a kind of displacement or a height map. So darker is a trough and lighter is a crest. So this is actually easier for an artist to make than a normal map. And it's also easier to see with your eye, where the bumps are, where the high parts are and where the low parts are. But this is useless for a shader, so you've got to convert that into normals that the shader can use. And that's what this is here. And these days, I don't know, I don't really see people using, I could be wrong, but I don't see people using bump maps and packaging them with models anymore. You just get the normal map. But bump map is an important intermediate step maybe as an artist creating a normal map by hand for something like like a floor texture or something like that. Something that isn't. I mean, you can get bump maps or normal maps by creating them by hand. You can also get them by having a very high resolution model and then baking out all those wrinkles and stuff into a normal map or a bump map, as it were. It's confusing because, often the words are used interchangeably, bump mapping, normal mapping, when they're very different. This is a bump map, this is a normal map. They're completely different. Anyways, I'm getting sidetracked. But get back onto the topic. The topic is some of these normal maps suck balls. Now, it just so happens that there is another Sponza that is in the GLTF sample models, the GL transmission format. And this one uses, GLTF. But I mean, it's still got all the textures. And it also has bump maps. Or not bump maps, normal maps. I'm getting myself mixed up here. You see the problem? It's very annoying. But anyways, it's got normal maps, and they're different. The generated ones, I think these ones are about the same because they're both generated from valid bump maps. But the normal maps for things like the ceiling and for the floor, they're completely different. For the curtains, they're completely different. And so I decided to pull those into here. Let's look at the Git history. What does Chili do? So Chili pulls in Sponza curtain from those models there, the one I showed you, the GLTF ones. So you see, they're very different. Well, you can't see this one because it got deleted. But what you'll notice is if you compared it to this one is much less crazy. It's much less bumpy. That one looks like someone splooged all over it with some kind of gold-colored splooge. This one is like, oh, that's just a little bit of gold filigree on some fabric. So I fixed the map, which fixed the splooginess, made it less hyperbolic. And also, I bumped up the brightness on this boy here to make the gold a little more shiny. And I see here the gold is a little less funky, and it's also more shiny. That looks nicer. That looks more metallic. Can zoom out here. Yeah, that looks mighty fine, if I do say so myself. And then I just gave the same treatment to basically all of the other normals that aren't normals that were derived from a bump map. So things like the Sponza floor was floor diff NRM, so we know that one wasn't derived from bump map. The ones that were derived from bump maps, they ended in DDN and they didn't have diff in their name. So I added this one from that other map, which is less crazy, and this specular. It turns out that I didn't like the specular in the end. I just took it out completely, but I might add it back in. We'll see how I feel about it. I gave the curtain, the fabric on it, I gave it a little more specular. So you can see I turned it from a pretty dark black to a more dark gray color. And so that gives the fabric a little more shine. And here I do the same thing for the other fabric map that we have here. That's the ones that are hanging up higher in the scene. Replace the normal map for the ceiling. Replace the normal map for just some detail things like a door that you can see in the side of the scene. And then what I realized was I was replacing all these normal maps from the other model, but the other model was also using OpenGL conventions, so I still had to flip the normals on those guys. So that's what I do here, just flipping normals. And here's the end result. We can see the floor is a little less bumpy and I don't know, flubby? Is that a word? That's a word, right? I'm gonna say it's less flubby. If you look at the curtain, we can now see a little bit of specular on the fabric as well. We got specular on the fabric, but not as much as on the gold. And I like this effect a lot. I think we got a really good thing going on the material. We could do even better if we added an alpha channel and we change the glossiness between the fabric and the metal, but you know what? This is good for now. Now, unfortunately, the floor here, I still don't like it. Look at this. It's still, like, can you see this? And I'm not going crazy here. It looks like it's warping as the light passes over it. It's still weird. And I guess we just can't fix that because it's not a real normal map. It's just something that's been derived from a diffuse map. It might be better than the other one, but it's still dumb and bad. Like, come over here. The wall, I showed you, the wall it has its own bump map. That's a proper derived normal map. Now let's look at the wall as I move the light up and down. It doesn't get all weird and stretchy. It doesn't look like the fabric of reality is being subtly corrupted. You know what I'm saying? It looks good. The floor looks dumb. The ceiling, it looks better than before, but I think it still looks dumb. It's just not as dumb. This guy looks cool. Look at how cool he looks. Watch when I move my Y. It looks like normal mapping is working. The floor looks very dumb, very bad. But what can we do? This is what we have to work with, okay? Beggars can't be choosers. What we can do is we can fix this. What the hell is this? What is this garbage? What is this supposed to be? This is supposed to be a plant. It looks like a disgrace. What is this? Also, I mean, when you zoom out on these textures, what's this weird pattern we're getting? It looks terrible. I hate it. Absolutely hate it.
It's rotten, 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 rotten.
Watch when I zoom out of this. It looks all like, look at this floor. It's all weird and speckly. That's dumb. So we can fix that and the curtain with MIP mapping. And then after that, we're going to fix the plant here. And can I see? Oh, yeah. And this chain. I don't know if you notice it, but the chain is really dumb. Yeah, now you see it. The chain is weird. So we're going to fix those things with the alpha blending / alpha testing. Now we're going to fix the curtain and all the texturing when we zoom out with MIP mapping. And those are going to be in the next 2 videos, and they're going to be real good. But until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button. It helps a lot. And I will see you soon with some more Hardware 3D.